Hello friends, welcome to our channel Learn Civil Engineering. In this video, we are going to discuss the theodolite. So let us start that. First, what is the purpose of the theodolite? So you know that theodolite is used to determine the horizontal and vertical angles. Okay, what is the purpose of theodolite? To determine the horizontal and vertical angles. Suppose if you use the compass, from the compass we can determine the bearings of the lines, and from the bearings you can calculate only the horizontal angles. But using the compass you cannot calculate the vertical angles at all. Then there are three types of theodolites basically. They are vernier theodolite, optical theodolite and electronic theodolite. So now if you see the least count of them, for the vernier theodolite, least count is 20 seconds, and for the optical theodolite, least count is 1 second, and for electronic theodolite, it varies from 2 seconds to 6 seconds. Okay, so whatever the vernier theodolite is there, its least count is 20 seconds, optical theodolite 1 second, and electronic theodolite 2 seconds to 6 seconds. And in case of vernier theodolite, theodolite is fitted with the vernier scale. Okay, in the vernier theodolite, theodolite is fitted with what? Vernier scale. And in the optical theodolite, theodolite is fitted with the micrometer. That's why the least count is very less here. Then if you see the electronic theodolite, it is fitted with the digital display. So whatever the angles you measure, directly they will be displayed instead of doing any calculations. Okay. Now for most important works, which type of theodolite we use? We use the optical theodolite because its least count is only 1 second. Okay, then whatever the vernier theodolite is there, its size is designated with the diameter of the lower plate. Okay, basically theodolite consists of lower plate and upper plate. So whatever the diameter of lower plate in centimeters is there, that is designated as the size of the theodolite. So sizes of the theodolite are designated like 8, 12, 15 like that. So when I say 8, size of the theodolite is 8, that means whatever the diameter of the lower plate of theodolite is there, that is how much? 8 centimeters, like that it is. Okay, so let us see the important parts of the theodolite. So first important part of the theodolite is a telescope here. So you can see the telescope here. So now whatever the telescope is there, it is of Kepler type. Okay, whatever the type, what is the type of telescope used in the theodolite? That is the Kepler type. And whatever the lenses we use, that is of the double convex lens. Okay, whatever the lenses we use, they are the of which type? Double convex lens. Okay, then theodolite consists of two parts, two plates like this. So one is the lower plate and another one is the upper plate here. Okay, so first if you take the lower plate, it is also called as a main scale plate. Okay, lower plate is also called as main scale plate because main scale is fixed on the lower plate. And on the lower plate 360 degrees. Okay, whatever the lower plate is there, that will be in the form of the circle. So 360 degrees are divided into 1080 divisions. Okay, 360 degrees are divided into 1080 divisions. So each division equal to how much? Each division equal to 1/3 degree, that is equal to 20 minutes. Okay, so whatever the least count of lower plate is there, that is how much? 20 minutes. Okay, then whatever the upper plate is there, that is also called as vernier scale plate. Okay, whatever the upper plate is there, that is called as vernier scale plate. Now if you are providing this upper plate, what is the use of that is it will improve the accuracy of the theodolite. So if you use only lower plate, the least count is 20 minutes, but if you are using the upper plate, the least count will improve here. So let us see how it will improve. On the upper plate we are fixing the vernier scale, and in the vernier scale 59 divisions on main scale are taken and they are divided into 60 divisions on the vernier scale. 60 divisions on the vernier scale. Then whatever the least count of the instrument is there, that will be equal to S by N. So what is S here is, S is the least count of the main scale, that is 20 minutes divided by N is the number of divisions on the vernier scale. Okay, N is what? Number of divisions on the vernier scale. So that is 60. So 20 minutes by 60, if you simplify that, 20 into for each minute 60 seconds will be there. So 20 into 60 seconds divided by 60, that is equal to 20 seconds. Okay, so this is the least count of the vernier theodolite. So hope you got the concept. If you use only lower plate, least count of the instrument will be 20 minutes But if you use the upper plate, which is the vernier scale plate, then least count of the instrument increases to 20 seconds. Okay, here it is not 20 minutes like this. It is, sorry, 20 minutes is written like this. Sorry. Okay, then next part here is the vertical circle. So whatever this vertical circle is there, it will be there on the left side of the telescope like this. Okay, vertical circle will be on the left side of the telescope like this, and this vertical circle helps in determining the vertical angles. So both the lower plate and upper plate, they helps in determining the horizontal angles, and vertical circle helps in determining the vertical angles. Next one, shifting head. This shifting head is used for the accurate centering. So basically by using the tripod legs, by moving the tripod legs, we will do the approximate centering, and to do the accurate centering we have to use the shifting head. Then next one is the plate level. What is this plate level is? It is the bubble tube. Okay, it is the bubble tube located on the plates here. This is the lower plate, this is the upper plate. So whatever the bubble tube is there on the upper plate, that is called as plate level. So this plate level is used to check the leveling of instrument. Okay, it is used to check the leveling of the instrument. So after doing the leveling, we have to see the plate level, and in the plate level, bubble should be exactly at the center. So these are the important parts of the theodolite. And next one is important terms of the theodolite. Okay, so what are these important terms is, first one is the line of sight. Now if you take the theodolite, it consists of telescope like this. On the telescope there will be, this is the eyepiece suppose, and this is the object piece. The eyepiece consists of the crosshairs like this. Now the line joining the intersection of the crosshairs, line joining the intersection of crosshairs to, this is the optical center here. Okay, this is the optical center of object piece to the optical center, that is called as a line of sight. Then what is horizontal axis is, if you see that, if you take the theodolite, that can be rotated in both horizontal plane and vertical plane. Okay, now if you want to rotate the theodolite in the vertical plane about whatever the axis the theodolite rotates, that is called as horizontal axis. So the axis about which telescope rotates in vertical plane, okay, not the horizontal plane, vertical plane. So that axis is called as horizontal axis. Then vertical axis means axis about which telescope rotates in horizontal plane. Okay, telescope rotates in the horizontal plane. So when I say vertical axis, that is the axis about which theodolite rotates in the horizontal plane. When I say horizontal axis, that is the axis about which theodolite rotates in the vertical plane. Next one is plate level axis. What is this plate level axis is, if you see the bubble tube in the plate level, it consists of bubble like this. Now when the bubble is exactly at the center, okay, when the bubble is exactly at the center, if you draw a tangent at the center of the bubble, okay, if you draw a tangent at the center of the bubble like this, then this tangent is called as plate level axis. So the tangent drawn at the center of the bubble, when the bubble is at the center, that is called as the plate level axis. Okay, then next term is swinging. So what is swinging is, it is the rotation of theodolite in horizontal plane. Okay, rotation of theodolite in the horizontal plane. Then next one is transiting. This transiting is also called as plunging or reversing. The transiting is also called as plunging or reversing. Very, very important question again. So now whatever the transiting is there, it is the rotation of theodolite in the vertical plane about 180 degrees. So if you rotate the telescope about 180 degrees in the vertical plane, what happens is eyepiece and object piece will exchange their position. Eyepiece will come into the position of object piece will go into the position of the eyepiece, like that it is. The next one, face left observation. So I told that if you take the telescope, on the left side of the telescope there exists a vertical circle, and when the vertical circle exists on left side, the vertical circle exists on left side, then what happens is, whatever the telescopic bubble is there, whatever the telescopic bubble is there, that will lies on the upward side of the telescope. Okay, that will lies on the upward side of the telescope. So in that case, if you take any observations, they are called as face left observation. So remember this point, very very important. Again, in the face left condition, vertical circle lies on the left side of the telescope and telescopic bubble lies on the upward side of the telescope. Now in the face right observation, vertical circle lies on the right side. The vertical circle lies on the right side, and whatever the telescopic bubble is there, that lies on the downward side of the telescope. Okay, that lies on the downward side of the telescope. So remember that you have to take both face left observation as well as a face right observation. Okay, so now what is the advantage of taking both these observations is it will eliminate the collimation error. Okay, taking both face left and face right observation, that eliminates which type of error? Collimation error. Okay, and process of taking both these observations, that is called as double sighting. Okay, process of taking both face left and face right observation, that is called as double sighting. Okay, so these are the important points in the important terms in the theodolite surveying. So in the next video, we are going to discuss about the adjustments of the theodolite. Adjustments of the theodolite. Basically, two types of adjustments are there that we will see in the next video. If you like our video, please share it to your friends and please subscribe to our YouTube channel. Thank you.